In this presentation, we will study about the sequential circuits, a very important presentation in the digital electronics course, because this is the base for your flip-flops, counters, and registers. All these three topics are very important, and there are so many questions being asked from these three topics only. So if you want to master these three topics, you have to understand what is sequential circuits first. That we will study in this presentation only. There is also a small change that you will find in the coming videos, and this presentation is the lecture number. I am mentioning the lecture number like this is 118th lecture in the digital electronics course. This will help the students who are learning the digital electronics first time. Okay, so let's move to the sequential circuits, what it is. When we talk about the sequential circuit, it becomes important for us to talk about the combinational circuits at the same time. Okay, because half of the definition of the sequential circuit is the combinational circuit. Let's see how. This is a formal definition for your sequential circuit. You can use this definition if someone asks you what is sequential circuit in your exams as well. So in sequential circuits, the present output, okay, the first important thing is the present output depends upon the present input. Okay, now these two things when combined together makes your combinational circuit. In combinational circuit, the present output depends only on the present input. Okay, we have to use word only here for the combinational circuit, because if I say I am having a combinational circuit that takes two input, the first input is, let's say, 1, and the second input is also 1, and the combinational circuit here adds these two numbers. So 1 plus 1 gives you 0 as the sum and 1 as the carry. Okay, so this is the result that we are having. Again, you are using this same adder, and you want to add 0 and 1, then the result will be what? 1 0. It has nothing to do with this output. Okay, what was the previous output? Let me explain you once more. You are adding 1 1. Okay, so you are getting the result 0 1. This is your output. Okay, now again you are adding different number, let's say 0 1, then the output is 1 0. Now this output, this is your present output that we are talking about. This present output is only depending upon this present input. This is your present input, this one is your past input, and this one is your past output. Fine. So this output, the present output, has nothing to do with the past input or the past output. Thus we call it as the combinational circuit. Okay, I hope you are getting this. But in case of sequential circuit, the present output depends upon the present input as well as it depends upon the past output or outputs. Okay, like in this case we are having two outputs, so it depends upon the past output or outputs as well. So this is the major difference between your sequential circuit and the combinational circuit. Let's see how it works. For example, this is my combinational circuit. This is my input, present input, and this is my present output. So the present output depends only on the present input. Now if I say I want to convert this combinational circuit to the sequential circuit, then what I have to do? Let's see. I have to take this output, all the three outputs actually, and then store it. I have to store it. Now let me explain you why I need to store it. Counter is the sequential circuit, and you already know that how counter works. Let's say if it is a decimal counter, it counts from 0 to 9. Every time it adds 1 to 0, then we will get 1. Then again it adds 1 to 1, we get 2. Then 2 plus 1 3, then 4 5 6 7 8 9. So every time it is adding 1 to the previous output, because 0 plus 1 gives us 1. Now when you add 1 to 1, we must know that this 1 was the previous output, because until and unless you know what was the previous output, how you are going to add 1. For example, if I am at 5, then the counter will count 6. It will count 6 only if it knows that the previous output was 5. Until and unless it knows what was the previous output, how it is going to add 1. So we require to store previous output. This is the very important point in the sequential circuit. We require to store the previous output. So what we need a memory. Okay, so what I am actually doing here, I am giving inputs, I am getting the output, and also at the same time and storing that particular output or outputs in my memory block. We will talk about this memory, very important point. This memory will keep the output till the time I am again going to use it. Let's say time came and we have to use the values stored in this memory, and these values will be used as the inputs. So let's see what we got here. We are having 3 inputs. These are our present input. Then we are having the output, and also we are having the memory element which has already stored the output from the previous inputs. So this will become our past output, and this past output will go to the input, and you can call it as the feedback, will go as the feedback, and the present output will depend upon this present input and the past output. So this is our sequential circuit. Now let me explain you the important point. What is this memory? Okay, because in sequential circuit everything is combinational. You can see everything is combinational except this memory and the feedback. So we have to focus on this memory, that what is this memory and how we are going to store the output. And as we are in the digital world, the output will be 0 or 1 bits, you can say. So we have to store the bits. How we are going to do that? If we know how to store a single bit, we later can store multi-bits also. So the first thing that came in the mind of the people is to use cascaded NOT gate. Okay, before that let me tell you, this memory is nothing but your flip-flops. Okay, I have raised the curtains, the suspense is over. This memory is your flip-flops. Okay, but people didn't get to the flip-flops directly, but they have thought different methods to store a single bit number earlier. It was the cascaded NOT gate arrangement that can be used to store a single bit. Okay, let's see how. These are your 2 NOT gates, and if the input is 1 or high, the output of your first NOT gate is 0, and then the output of your second NOT gate is 1. So you can see that this 1 is stored